In this video, we're going to go ahead and cover section 2.5, zeros of polynomial functions. This is, just to kind of give you a heads up, a pretty long subchapter or subunit. So we might have to divide it up into about 3 videos, okay? Just giving the heads up here. The beginning of this is just some definitions, actually some theorems. We have the fundamental theorem of algebra, which is kind of a big deal, okay? It states that if f of x is a polynomial of degree n, where n is positive, okay, then f has at least one zero in the complex number system. Remember that the complex number system is made up of real numbers and imaginary numbers. So if that zero is just real, it's still considered a complex number, okay? This theorem relates right into the next one, which tells us that if f of x is a polynomial of degree n, where n is positive, okay, then f of x has precisely n linear factors. So in other words, whatever the degree is of this, we're going to have that many factors like so, where you have, so these parentheses here represent our factors, okay, where c1, c2, etc., all the way to the last c of n, are complex numbers. Okay, so this can be a combination of reals or imaginary, one or both, just depends, okay? So we're going to go ahead and use these theorems to solve some problems here. Our first example is to determine the number of zeros for the following. We have two different functions going on here. We're going to go ahead and work on letter A first. We should know by now that when we're solving or trying to find a zero, same thing, we will set our function equal to 0. Okay, so the first thing you want to do here is set this equal to 0. So 0 equals x to the fourth power minus 1. Okay, I can see from here, I'm going to assume, and I'm probably hoping it's right, that this is a difference of squares because you have x to the fourth power, which could be, the square root of this is going to be x to the x squared, and the square root of 1 is 1. So I'm going to rewrite this as a difference of squares. So x squared plus 1 and x squared minus 1. Okay. So this again was a difference of squares. I'm not going to write it down. I think we've done it several times already. From here, well, I'll deal with this one in a bit. But I know that this one right here, x squared minus 1, is another difference of squares. So this guy, x squared minus 1, can be written as x plus 1, x minus 1. Okay, so these are now in factored form, so I'm pretty much done with those. I'm going to see if I can further reduce this one. Okay, so a little bit of side work on this one, just so we can kind of see how this one's going to work. I'm going to set that equal to 0 to further factor this, which is going to give me x squared is equal to negative 1. And we know that we can't take the square root of a negative, but we also know that we can take the square root if we're dealing with imaginary. So if I take the square root of both of these, I will end up with x equals plus or minus, okay? Remember, the square root of negative 1 is just going to be I. So this means that these factors right here for the purple part here are going to be x plus I and x minus I, okay? So my factors in total are going to be all of these. Let me bring these down. So x plus 1, x minus 1. Okay, so this is going to give us our zeros. And I mean, I kind of have two already here, but our zeros from here would be x equals plus or minus I. So there's two of them. And x equals plus or minus 1, those two. And we can see that there are 4 zeros for this one, which is the degree of our polynomial. Okay, let's try the next one. So for this one, we have f of x equals x cubed plus 4x. Let me try to center that out. There we go. So we're going to do the same thing. We're going to go ahead and set this equal to 0. So 0 equals x to the third power plus 4x. This one might not be as complicated. We're going to go ahead and factor out an x. So we have x times x squared plus 4, okay? And the first one is kind of easy because this one, when you set equal to 0, it's just x equals 0. So there's one of them. So this one would just be x is equal to 0, okay? This one's going to follow the same format we did over here. So when I set x squared plus 4 equal to 0, we end up with x squared is equal to negative 4, square root both sides, so x is going to be equal to plus or minus 2i. So we have 3 zeros for this one. Okay, 1, 2, 3. And if I wanted to write these as factors, okay, I would do so like this. I can say that f of x is equal to x times x plus 2i, x minus 2i. And if I did this correctly, if I wanted to check it, I can also multiply this back out and it will give me my original polynomial function here. Okay, so this one has 3 zeros, which makes sense because we have a degree of 3, n equals 3. Okay, next one. This next page has a bunch of definitions. Okay, so we have our first one here at the top called the rational zero test. Okay, so the rational zero test, I'm trying to get it all here on the screen. Okay, says that if the polynomial f of x looks like this, where you have the degrees going down, so descending order, okay, so a sub n, x to the n, and it just goes down from there, all the way to a sub 0, which has no x, because the x that would be here would be x to the 0 power, okay, has integer coefficients. In other words, all of these guys, my x to the n, a to the n, a to the n minus 1, a to the seconds, a subscript 1, I should say, not 2, subscript. If these are integers, like whole numbers, okay, then every rational zero of this function has the form p over q, okay? If you don't remember what a rational number is, then here's a quick lesson. A rational number is pretty much any number that can be written as a simplified fraction, okay, where these two have no common factors. That's why I'm saying simplified, other than 1. Um, Please note that if it's divided by 1, so say, for example, 2 over 1, that is still considered a rational number, okay? The only one this is not going to apply is pretty much the irrational numbers. So you're thinking like pi, e, anything that has, non-repeating or any kind of pattern decimal is not going to fall into this. So there's actually quite a few rational numbers we have, okay? Where p is the factor of the constant term, okay, so a's of 0 is going to be our constant right here. So factors of this guy are going to be known as p, and factors of the leading coefficient, so that's this one up here, are going to be q. So when you're thinking about this, if this helps, okay, we can say a sub n, you're going to be looking at for the bottom one. So this is going to be my factors of a sub n, okay, when we consider these rational numbers. And my pen got stuck here. A sub 0, which is our constant, are the factors we consider up here on the top. Okay, so there's kind of a process to this. What we're doing is we're trying to find zeros if they don't give us any, trying to find possible zeros that could be um, zeros of the function. So here is the method. Okay, number 1. We make a list of all the p and the q values. So remember that p is the factors of the constant term. So this is like the last a sub 0. And q are the factors of the leading coefficient. So we have to make a list of all the factors of each. Okay. Then after we do that, we're going to write down all the possible combinations of P over Q. So whatever these numbers are up here, we have to divide them by these numbers, all the combinations. So it gets kind of lengthy in some problems. Step number 3 is once we have that list, we're going to evaluate each of those and see if it's equal to 0. We only do this if there's only a few. So there's like 1 or 2, then, we just plug them in and see if it comes out to 0. And if it does, then we're done. Okay, if not, then, we might not have as many zeros as we thought. We have to have at least one, right? Or we can use synthetic division if there's a whole bunch. But if we do this, it does have to have a remainder of 0 to be considered a 0. So we're going to go through both of these processes in 2 separate examples. Here we go. Example number 2. Let me there we go. It says find any rational zeros. F of x is equal to x cubed plus 2x squared minus x minus 2. So I have, in this example only, okay, I'm going to outline the steps. Step number 1 is to find all our factors of p and q. So I'm going to label my p and my q. My p is going to be the constant term. So in this case, -2 is our constant term, okay? So factors of -2 are going to be plus or minus 1, because 1 goes into that number, and plus or minus 2. And that's it. Those are the only factors of -2. Factors of my q, remember q is the leading term, so q is gonna happen over here. There's actually a 1 there, so I'm gonna just put it there just for my own, sense of ease here. And the only factors of 1 are plus or minus 1. Okay, so this one is not too bad. It looks like we can probably only have a few combinations. So for step number 2, I'm gonna just combine these. Okay, I'm gonna say P over Q. So the first combination I have is +1 divided by +1. So 1 over 1 is one combination I could have. Okay. Another combination I have is I can make it negative, right? So -1 over, well, if I make this one negative, it's going to stay positive. So I'm just going to put over 1. Okay. And then I'm going to look at the next number. So the next number I have is 2. So I can have 2 over 1. So 2 over 1. Or I can have -2 over 1. Please note that I could put it over -1, but it's gonna, if I do something like this, let's say I do -2 over -1, and I can write it down if you want. But notice that this is gonna be the same as this one. Okay, so once you have your combinations, you can do another step if you would like. This is kind of optional, but you can kind of like just reduce them. So like 1 over 1 would be 1, right? -1 is going to be -1. This one right here. 2 over 1 is just 2. -2 over 1 is just -2. And this one is +2. We already have it. So these are all my possible zeros. Okay, so since we don't have that many, we only have 4, we can probably just plug them in and see which one is going to give me a 0. Okay, so step number 3 is to go ahead and do that. We're going to evaluate f of p of q. So we're going to do this, okay, which in this case is these 4 numbers. So we're going to test x equals 1 for our first one. So f of 1, okay, and all I'm going to do is plug this into my original function up here. So 1 cubed plus 2 times 1 squared minus 1 minus 2. And that's going to give me, let's see, 1 plus 2 is 3, 3 minus 1 is 2, 2 minus 2 is 0. So woohoo, we already found one. This means that x equals 1 is a 0. So we found one, okay? Let's test another point. we're going to test x equals -1 next. So same thing, f of -1 equals -1 cubed plus 2 times -1 squared. Okay, so from there, we're going to go ahead and test the next one. So far we have 2 zeros. So we're on a good path here. So we're going to test now 2. So we're going to test x equals 2. So same thing, f of 2 equals 2 cubed plus 2 times 2 squared minus 2 minus 2. That's going to give me 8 plus, let's see, plus 8, I believe. Yeah, so 16 minus 2 is 14, minus 2 is 12. So this one is a no. So this one is not going to be a 0. Okay, but hopefully it's that last one because this one can have up to 3 zeros, right? So now we're going to test our last one, which is x equals -2. Okay, and we do the same thing. F of -2 is equal to -2 cubed plus 2 times -2 squared minus -2 minus 2. You want to make sure you plug everything right so you don't make any mistakes. Hopefully I don't in this one. So this is going to be -8, okay, plus 8, which is going to be 0. And then this right here is going to be +2. 2 minus 2 is 0. So it looks like we found our third 0. Okay, and now that since I have some room here, I'm going to go ahead and just do a quick little sketch here of that graph. So that would look something like, let's see, -2, -1. So we have points here and here. We also have a 0 at 1. Based on my polynomial, since it is an odd function and it's positive, so remember this from the previous notes, since our n is 3, it's odd, okay? And our leading coefficient, so I'm going to call it a sub n, is positive. I'll do it this way. Since it's positive, greater than 0, okay, that means that the end behavior should be like so. So from here, I'm going to go ahead and do that. So there's that one, and it might be something like, maybe like this, okay? And that is it for this problem. So we found our zeros, we even sketched a nice little graph of it, okay? So let's go ahead and try another one now using the synthetic method. So here we go. You're going to see there's a lot of examples in this one. Let's find the rational zeros of this function. F of x is equal to x to the fourth minus x cubed plus x squared minus 3x minus 6. Okay, so step number 1 is to go ahead and find all my possible values of p and q. Okay, so I'm going to do that first. I'm not going to, I guess I can still color code if you'd like. So I'm going to go ahead and do all my p values. Remember, p is going to be this number, the constant, the one that does not have a variable next to it. Okay. So p in this case, factors of -6 are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So you can already see just with the p alone, we have quite a few. Okay. We're going to look at q now. So q comes from the first one. So in this case, it's just that one right there. Okay, and I can do that. I'll put the q right there. So that one's kind of simple. It's just plus or minus 1. Okay. So all the possible combinations for this then are just going to be basically the p, because if we divide these by 1, right, 1 divided by 1 is still 1, 2 divided by 1 is 2, 3 divided by 1 is 3, 6 divided by 1 is 6. Whether it's negative or positive, it's still going to be pretty much this list right here. So my possible combinations, so possible, we'll say possible rational zeros, that's what we're really looking for, right, are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, so what I'm going to do is I'm going to use synthetic division with some of these with one at a time, I guess you could say. And the minute I find a 0, I can actually continue the synthetic division to find another 0. Okay, so here's how it's going to work. This is like our step 3. Okay, if you wanted to kind of label it a little bit here. I'm going to try we're going to try x equals 1 because that's probably the easiest one to do, okay? Using synthetic division. So using synthetic division. So if I use synthetic division, my little box here is going to have that one, okay? And I'm going to take all my coefficients of this up here. So 1, -1, 1, -3, and -6. And I'm just going to, oh, a little bit crooked there. Just going to go ahead and do that real quick. So bring down my 1. 1 times 1 is 1, so there's that one. 0. 1 times 0 is 0. Give me 1. 1 times 1 is 1. -3 plus 1 is going to give me -2. 1 times -2 is -2, and this is -8. So this is not going to work because this one is not equal to 0. So x equals 1 is not going to work because of that. Okay, so if you want to make a note for yourself, just at least for one of them, since the remainder, remember this is the remainder right here, is not equal to 0, x equals 1 is not a 0. So we have to try another one, okay? Okay, so now we're going to go ahead and try another one. Let's try x equals -1, okay? So I'm going to kind of make it just a little bit smaller. Sorry guys, I had to use a different paper because I scribbled really badly. So I'm not going to even try whiting that out. So excuse the paper here. So this is -1 little box, okay? We use the same exact coefficients in 1, -1, 1, -3, and -6, okay? And we're going to go ahead and do our synthetic division with that. So hopefully by the end of this video, you are very good at synthetic division. So bring down the 1. -1 times 1 is going to give me -1. These 2 is -2. -1 times -2 is +2. 1 and 2 is 3. -1 times 3 is -3. These two together, -6. -1 times -6 is +6. And that gives me a remainder of 0. Yay! That's what we wanted. So this is going to be one of the zeros. So since r equals 0, r is a remainder, okay, then x equals -1 is a 0. Okay, so we have one of the zeros so far. We're going to try it again because we still want to see if we need to have, we can have up to 4 zeros for this one, right? So since the degree is 4. So what I'm going to do is, since I already have one of the zeros for sure, I can actually go continue the synthetic division with this right here. So this right here is going to be the same as 1x squared minus 2x, oh, I'm sorry, 1x cubed, not squared. 1x cubed minus 2x squared plus 3x minus 6, right? So I'm going to use this one now and divide this one by whatever I have left, just because it's less digits, and I'm allowed to do that because if this divides into the original, then the other factor should divide into this as well, okay? So here's how it's going to work. We're going to try another one. Now we're going to try x equals 2 because that's the next one according to what I have up here. So we tried these two, we're going to try a 2 now. Okay, and we're going to do the same thing. So there is my 2, and I'm going to go ahead and use these numbers this time. So 1, -2, 3, -6. Okay, same deal. Bring down the 1. 2 times 1 is 2. -2 and 2 is going to give me 0. 2 times 0 is 0. That gives me 3. 2 times 3 is 6, and that gives me a 0. So we found another 0. See how cool this is? So far we have x equals -1 and x equals 2. And then from this one, if I were to rewrite this one, you're going to see that it's going to look a little interesting. So now from here, I'm going to jump over to this side, and I'm going to say this right here is going to be x squared plus 0x plus 3. And if I were to set that equal to 0, so I should have done that up here too, you're going to see that this one, we can actually probably solve it straight out. We don't have to do any synthetic division with this one, right? This one is not going to have any, and we can work it out if you like, so you can see. If we subtract 3 from both sides, we get x squared is equal to -3. And if I take the square root of that, okay, well, we're going to end up with something kind of weird, something like this, plus or minus the square root of 3i, which is not going to work for us because the square root of 3 is not an integer that we can put. It's not going to be a p or a q, so to speak. We can't put it into a fraction form of simplified form, so this is not going to work for us. Okay, so we're pretty much done at this point. So what I would do here is I would go ahead and say, well, my f of x, okay, which was equal to x to the fourth, and I'm just rewriting it, minus x cubed plus 2x squared minus 3x minus 6 is the same as my two zeros. So my two zeros were x equals 2, which if I were to put in factored form would be x minus 2, okay? And this one, which again, if I put in factored form would be x plus 1. So I'm going to put those two here now. So x minus 2 times x plus 1 times that last one that I found here, this one. That's not going to give me any zeros. So x squared plus 3. Okay, and my zeros, let me go ahead and show you that. I know it's a lot of work, guys. My zeros in this case are x equals -1, comma 2, and those are the only rational zeros. I should say rational zeros. Okay, these ones are going to be zeros as well, but they're going to be decimals pretty much. They're going to be approximations. So if you wanted to put that here, we can say other zeros, okay, would be x equals plus or minus the square root of 3i, which is some really weird small decimal that's probably not even going to, well, it's not going to actually cross. It's going to be a little bit above or below, okay? So that's it for that one. Let's go ahead and do one more. Okay, so for this example, you're going to be a little bit intimidated by that really big number at the end. So -125 is our p. Okay, it's the constant term here. So for just like we did before, we're going to go ahead and list all the factors of this huge number. Okay, so I know for sure it's plus or minus 1. Then I have plus or minus 5, plus or minus 25, and then plus or minus, I want to say 120. Yeah, 125. I think those are going to be it. Um, Pretty sure. And then we do the same thing with Q. In this case, you can see that our Q is just the 1 again. Sorry, I kind of swapped the colors here a bit. That's okay though. So this means that all my combinations are going to be pretty much just like the one before, because anything divided by 1 is itself, right? And if I throw a negative in there, it's just going to be, plus or minus. So from this right here, I can get my combination. So my possible rational zeros, okay, are going to be basically this list right here. Plus or minus 1, plus or minus 5, plus or minus 25, and plus or minus 125. For something like this one, I'm going to go ahead and let you use a graphing tool just to kind of help us a little bit and see more or less where it might land, okay? So I'm going to use the Wabbit Emu one just for this one right here. Let me type it out super quickly. Okay, so here is my function, and here is the graph. So you can see that it's kind of in the lower, we can zoom out so we can kind of just see what's going on here. So it looks like this one actually only has the 1, 0. Okay, so it has 1, 0, and it's pretty early on. So I'm going to say it's probably going to be either the 1s or the 5s. Obviously, I can zoom in and see what it is, but this is just to kind of help us kind of see between what values our 0 is going to be. So I'm going to go ahead and try. I know it has just the 1, okay, so I'm going to try the 1 and the 5, and I'm going to do this one using the first method, where you just plugged in the numbers, because it's only going to be a few in this case. It's going to be maybe these 4 guys, okay? And I know it's kind of obvious which one it is, but just to go through the motions here. Okay, so f of -1 is going to give us -1 cubed minus 15 times -1 cubed plus 75 times -1 minus 125, okay? And if we, oops, and if we calculate that, we should end up with negative 216. So that is not a 0. Okay, so this is a no. Let's try f of 1, same deal. 1 cubed minus 15 times 1 squared. Oh, I should have put a squared here. I'm sorry, guys. Plus 75 times 1. And I did pre-calculate these, by the way, just because they're bigger numbers, so I didn't want to take too much time doing them live. So this one's going to come out to negative 64, which again is not equal to 0. Okay, f of 5. So same thing, 5 to the third power minus 15 times 5 squared plus 75 times 5 minus 125. And this one, if I remember, is exactly 0. So we have found our rational 0. So our 0 in this case is going to be, I guess I can put it right here. Our rational 0 is going to be x equals 5 for this one. Okay, which means if I were to do it, no, I'm not going to actually do it, but if I were to do the synthetic division with this one, whatever I'm left over with is probably going to be some kind of irrational number, meaning it's going to be decimals that don't quite have an ending, okay? Something that cannot be written in terms of a uh, simplified fraction. Okay, so there's my rational 0. Okay, and that's it for that one. So I think I'm going to stop the video here because I think, yes, the next topic is solving, more solving. So we'll go ahead and see you in the next video.